cancer, violence, aggression, obesity, stress. If you want to fix all your complex problems, well, this is controversial, but the vast majority of the evidence suggests that
Daniel Lieberman, a Harvard professor who uses the information of our evolutionary past
to understand the health crisis we are in today and educate people on how to live a long, healthy life.
the vast majority of us in the Western world will die from a mismatched disease. Chronic stress, that's what we call a mismatch. Obesity, heart disease, many cancers are mismatches. And it's because we now live in a world where we're able to have incredible levels of comfort with all this choice. For example, the number one medical complaint is back pain. Because I'm sitting in this comfortable chair, I don't have to use any of the back muscles. So we develop weak backs that don't have any endurance. We know that people who sit a lot at work, but then also sit a lot in their leisure time, run way more risk of disease. And if you aren't physically active, you don't grow as much skeleton. And then when you hit 25 to 30, for the rest of your life, you're going to start losing bone.
Oh, sugar.
Even in this highly sanitized world, we're much more likely to develop allergies and various kinds of autoimmune diseases because our immune systems are so unchallenged, they end up accidentally attacking us. Also, famous studies show that the richer the country, the higher the rate of cancer. Bangladeshi women who move to England, their cancer rates go way up because of diet and physical activity and stress, things that have changed in our modern world for which we are very poorly adapted.
There's a lot to take in. Is there an actionable conclusion that I can do today that is going to reduce my chances of getting one of these mismatched diseases?
Yes, I think there's two. The first is...
Quick one. This is really, really fascinating to me. On the back end of our YouTube channel, it says that 69.9% of you that watch this channel frequently over the lifetime of this channel haven't yet hit the subscribe button. I just wanted to ask you a favor. It helps this channel so much if you choose to just subscribe. Helps us scale the guests, helps us scale the production, and it makes the show bigger. So if I could ask you for one favor, if you've watched this show before and you've enjoyed it and you like this episode that you're currently watching, could you please hit the subscribe button? Thank you so much, and I will repay that gesture by making sure that everything we do here gets better and better and better and better. That is a promise I'm willing to make you. Do we have a deal? Daniel, what is your job title?
I'm a professor of human evolutionary biology at Harvard University.
And what does that mean?
It means I get to have a lot of fun. I study... Well, my department studies how and why humans are the way we are, and we're also interested in how and why that's relevant to humans today. My particular specialty is I study the human body. I'm interested in how and why the human body is the way it is and how that's relevant to health and disease. And I'm most of my work is on the evolution of human physical activity, but I'm also interested in diet and other ways in which we use our bodies.
Why does it matter?
Well, because we weren't designed, we weren't engineered, we evolved, right? So if you understand why we are the way we are, you have to understand that evolutionary history. And if you want to solve problems, if you want to deal with, big issues that we face today, obesity, heart disease, cancer, violence, aggression, all of these things have an evolutionary origin. And an evolutionary origin is crucial to helping us come up with solutions.
Does what we eat play a role in the sort of starting point of our stories and how we began to eat? I'm thinking about farming, hunter-gathering, and all those things. Because when I look at human beings versus a lot of animals, and you talk about this in the book, we are remarkably fragile and inadequate in comparison. Like our eyesight isn't that great. We're like super weak. I think you say that like most monkeys are stronger than we are. Squirrels can run faster than us.
Well, I think we actually exaggerate our fragileness and weakness to some extent. So chimpanzees, our closest relatives, are probably about 30% stronger than we are. You would not want to arm wrestle a chimpanzee, right? And most quadrupeds can run way faster than we can, right? We have this sort of story about human evolution that it's been a sort of triumph of brains over brawn, right? That we have tools and language and that has enabled us to sort of conquer, the world and become the dominant species. And there's some truth to that, of course. So technology, language, communication, cooperation, all are essential parts of the human success story. But, I think as athletes, we're pretty impressive. We can outrun most animals over long distances. So we're really impressive in terms of endurance, both men and women. We can throw, we can kick, we can do all kinds of things that my dog can't do. As far as diet is concerned, we're the ultimate omnivores. We can eat anything. Most animals have very kind of constrained diets. There are certain things they can eat. Most of the things out there they cannot eat. we've managed to figure out because of technology, cooking, food processing, but also because of the nature of our digestive system, we can eat just about anything on the planet, right? People can be vegans. They can be, they can eat all meat diets. They can, it's astonishing how much variety humans can get by with. Our livers can turn anything into anything. We can turn fat into carbohydrates, carbohydrates into fat. We have an incredibly astonishing range of foods that we can consume.
When we're thinking about our sort of evolutionary history and the hunter-gatherer tribes that still exist in the world, I think I've fallen into the trap of believing that all the answers we're looking for about how to be healthy humans in the modern world can be found just by looking back at our hunter-gatherer ancestors. Is that true, that they hold the answers to how to live a happy, healthy life?
Well, it's like everything is complicated, right? I mean, to some extent, we call that paleo fantasy, this idea that if you just go back to being a hunter-gatherer, that you'll have no problems, right? And that hunter-gatherers have no violence and they don't get sick and, all is well. Well, it's not so simple, right? I'll give you one example. Murder. We have this idea that, humans have become incredibly violent since the origins of farming, right? But if you actually look at the ethnographic record, hunter-gatherers are just as violent as the rest of us. They're human beings. They kill for passion. They kill for greed. They kill for, there's murder. There's warfare among hunter-gatherers, even in some parts of the world. Yes, it's true that hunter-gatherers don't have the same problems with obesity. They don't have metabolic syndrome. They don't have, they probably don't get heart disease, at least to the extent that we do. There are plenty of things that they do that are worth emulating, but they're not role models in every respect. And what natural selection cares about is how many offspring we have who survive, right? That's the only thing natural selection cares about. It's the equation of life is food in, babies out, right? That's what we're here for, right? As far as natural selection is concerned.
Not happiness.
We're not here to be happy. We're not here to be nice. We're not here to be fulfilled or anything like that, although it's good when that happens, right? We evolved to be hunter-gatherers. Our ancestors were hunter-gatherers for millions of years, but the adaptations they have are primarily and first and foremost about reproductive success. So we didn't evolve to eat foods to make us healthy. We evolved foods that would increase our reproductive success. And we evolved to be healthy only to the extent that health promotes reproductive success. So you can't just assume that because our ancestors did something, it's optimal for health. It's more reasonable to assume that that's optimal for reproductive success. And remember, it's in those environments and in those contexts, and things have changed.
Talking there about what they eat, one of the big debates I guess that's an ongoing debate, is whether we are evolved to eat meat or we're meant to be, interesting use of words, vegans or vegetarians. What's your perspective on that? Because I've sat here with people who are really, really passionate about the fact that we're not supposed to, evolutionarily, see how quickly I tried to say that word because I don't know how to say it, meant to eat meat.
Well, that's just nonsense. I mean, humans started eating meat about 2.5 million years ago. There's no question, at least 2.5 million years ago, maybe more. And there was no question it played an extremely important role in our evolutionary history. Even chimpanzees, our closest cousins, eat meat occasionally when they can. They don't get it very often. Maybe about less than 5% of their diet is meat. From an evolutionary perspective, we evolved to have meat as part of our diet. But of course, you can be a human being and not eat meat and do just fine. In fact, there are some advantages. Because remember, we didn't evolve to be healthy. So just because our ancestors ate meat or didn't eat meat doesn't mean that's optimal for health today, right? That's a very sort of impoverished way of thinking. It's just illogical, right? Our ancestors didn't evolve to read. So should we not read? Reading is only a few thousand years old, right? So it doesn't, that's just not the right way to think about how to use evolutionary theory and data. The fact of the matter is that we evolved to eat just about everything. We are the ultimate omnivores. It's astonishing the range of foods that we eat. Hunter-gatherers eat, a typical hunter-gatherer for example, there's data from the Kalahari. I think they eat about 800 different kinds of plants, many different kinds of animals, right? And that's just the Kalahari. Humans moved over the last, few 100,000 years to pretty much every corner of the planet. And in every part of the world, they found foods to eat. Humans live in the Arctic, where there's almost nothing but meat to eat in many seasons. And where you get plant food in the Arctic in the winter? By eating the contents of the intestines of of the animals that they hunt, right? People evolved to live by oceans and fish and dive for shellfish and eat shellfish. I mean, it's they live in rainforests and eat bugs and birds and monkeys. I mean, everywhere you go on the planet, people figured out to eat various kinds of foods. And one of the ways that we became so omnivorous is that in addition to having an incredibly flexible digestive system, we also have technology to process our food. So by cooking our food, by fermenting our food, by grinding, cooking, cutting it up, we've been able to essentially adapt ourselves to an astonishing range of environments, hence an astonishing range of foods. And so now tell me, like, what diet are we evolved to eat, right? It's an impossible question to answer.
Is there a point in our history where we learned how to hunt and gather? And was that the point where we started really eating more meats?
Yes. So, well, first of all, it probably wasn't like a
day.
A lightning bolt came down from the sky and all of a sudden, bam, so we figured out how to hunt. After all, our ape cousins will hunt when they can. But as soon as we became bipeds, which is probably around 7 million years ago, we walk on 2 feet, right? We became slow, right? Chimpanzees, when they run, can gallop essentially on 4 legs, right? And they can be really fast. They can't run long distances, but boy, are they amazingly fast. And they can climb up trees like no human can. Around 7 million years ago, when we split from the chimpanzee lineage, it looks like we became obligatory 2-legged bipedal creatures. And when you have only 2 legs, you can only run half as fast as when you can have 4 legs. It's like having a cylinder car with half the number of cylinders, right? You can just produce less power, right? And so our early ancestors must have been slow. There's no way they could have run that fast, and certainly not fast enough to be great hunters. So I suspect that compared to chimpanzees, they were probably poor hunters because they couldn't run down creatures the way chimpanzees could, right? So probably for a few million years, meat was probably rare in the diet. But then we begin to see, starting around 3 million years ago, maybe a little bit older, stone tools in the archaeological record. We find bones with some cut marks on them. And starting around 2.5, 2.6 million years ago, we have archaeological sites with bones of animals with cut marks on them, stone tools, and those animals were clearly butchered. And by 2 million years ago, we have clear evidence that humans were actually hunting. We have clear evidence that these animals weren't just scavenged; they were definitely hunted. So that means that sometime between around 3 and 2 million years ago, hunting became part of our ancestors' repertoire. They're also making tools. They must have been cooperating. They probably had some form of communication or whatever. We don't know exactly what it's like. And they're probably eating a wide range of foods, including what we call extractive foraging. So they're eating tubers, underground storage organs, right? So instead of just plucking berries off plants, they're actually finding high quality foods that you have to dig for, right, under the ground, right? It's like, just think about a potato. It stores its energy underground. So these are rich sources of food, but you have to be able to dig for them and find them, right? So this combination of extractive foraging, so not just plucking leaves or berries off plants, but finding high quality resources, hunting, cooperation, tool making and tool using, all together, that's the hunter-gatherer way of life, right? And that emerged sometime, again, between 3 and 2 million years ago, and that was transformative. That's really, I think, one of the most important shifts that occurred in human evolution. And that's also, incidentally, when we see this shift in our bodies, right? When we going from being essentially more ape-like, like Australopiths, which had short legs and long arms, and they have small brains, and they're not apes, but they're more ape-like, to basically bodies that are more or less like yours and mine. So we have a fossil called the Turkana boy. His real name is Narya Kotame. He's from the west side of Lake Turkana, northern Kenya. He's a Homo erectus who was probably about 8 years old when he died. And, from the neck down, he's basically like you and me. His head is not quite like ours, but he still has a big brain, not as big as ours. He doesn't have a snout like an Australopith. He's got a vertical face. He's got teeth that are basically like yours and mine. He's basically very, on that path towards being a human. And so hunting and gathering and the genus Homo kind of come together. And that was, I think, one of the most important major shifts that occurred in our evolution. Maybe the most important, actually, more important than even the evolution of our own species.
And that allowed us to become good hunter-gatherers. So we have this nose that sticks out of our face, whereas like a lot of our cousins look more like Voldemort, like they kind of have the invert. And that's a sign of when we became hunter-gatherers, right?
Yeah. So that external nose, right? So a chimpanzee has a flat nose like a dog, right? Mm-hmm. And that external nose that you and I have, which is, of course, fantastic for holding our glasses, right? Well, you don't have glasses. Not yet, at least. We think it's a kind of a humidifier. So when air goes into our nose, it has to go through a little nostril. So it's a little, what's called a venturi throat. So it goes through a very narrow bore and then into a larger space. And it has to turn a right angle to get into the inside of our nose. And then it has to turn another angle to get down into that pipe. We call that the pharynx that brings air down to our lungs. And all those twists and turns and changes in diameter cause the air to be more turbulent. So the air, instead of flowing in a kind of a straight, right? Because it has these vortices. It's got all kinds of currents. And when that happens, that means that the air has more contact with the mucous membranes in our nasal cavity. So it can pick up moisture on the way in, mm-hmm. pick up heat on the way in, so our lungs don't get dried out. And on the way out, it can recapture that moisture so that we don't lose that moisture when we're walking, or for that matter, running. So if you, on a really cold day, you can do a simple experiment, right? When it's below freezing, if you breathe out, right, you see all that steam coming out. Do the same thing, breathe out through your nose, you'll see a lot less steam. And that's evidence of this ability of our noses to trap air. And that's because of this external nose. So that happens around 2 million years ago or so. We can see that because in the fossils, we can see the margin of the nose, and you can see that it's lipped out. It's what we call everted, right? It sticks out, and that's evidence that we had these cartilages that stuck out and gave us our modern nose. So if you went 2 million years ago and you met your ancient ancestors, they would have had a nice schnoz.
What does this say about how we breathe today? Because there's been a huge conversation, I think, over the last couple of years about breathing and breath exercises and mouth breathing in particular. I've had people on this show like James Nestor who talks about how there's a lot of disease happening because we've kind of by habit become mouth breathers when we run. But also, so many people seem to be having a lot of problems with their sleep. My girlfriend, for example, she uses nasal strips when she sleeps to try and open up her airways. And I actually think she's going to have an operation. But we've even got people in our team that seems like everyone's nose is, what do they call it when it's bent? The middle.
A deviated septum.
A deviated septum. Seems like everyone's struggling with this at the moment.
Yeah. I have to say, I'm a little skeptical of some of these arguments. The idea that you can fix all your health problems by just breathing through your nose. Look, breathing is obviously very important, but the idea that, for example, when you run, you should only breathe out through your nose, that's just silly. That's just not true. We evolved to breathe out of our mouth when we run. We're the only species that does that, actually, because it's an efficient way to dump heat. When you're running, you're generating huge amounts of heat. You have to dump it or you're going to overheat. And you breathe out through your mouth for that reason, right? To kind of to get the heat out of there, right? Breathing through your nose would be maladaptive, and no elite runner on the planet breathes out through their nose when they're running. I'm not sure where that came from. And I'd just like to see more data to support some of these arguments about nasal breathing. I'd like to see data to support the effectiveness of those nasal strips. Sure, breathing is important. There are better and worse ways to breathe. We're always looking for simple solutions, right, to complex problems. And the idea that somehow fixing your breathing is going to prevent you from having a wide range of diseases is not true. And people who have sleep apnea, which is a serious issue, that's usually caused by a variety of things. Of course, a deviated septum might be one of them. Obesity can cause it. There's a number of other problems. And of course, once that occurs, again, you want to treat the cause, not the symptom, right? So the best way to treat the cause of the apnea is not to put a piece of tape on your nose. It's to find the underlying cause about why that's happening in the first place and solve that and deal with that.
And is sweating sort of correlated to that turn in the fork in the road in our sort of hunter-gatherer history, because monkeys, and even my dog Pablo, he doesn't seem to sweat from anywhere other than his mouth, I guess. It seems like his panting is his way
Exactly. So the way in which most animals cool down is by panting, right? They breathe through their mouth or their nose, right? And there's air passes over these mucous membranes in the nose and the mouth, and what happens is that the air, by passing that air over the tongue or whatever, causes you get evapotranspiration, so evaporation. So the air, the moisture in that goes from a liquid to a gas phase, right? And that, of course, costs energy. So because of conservation of energy, that means that for every, I think, milliliter of oxygen of water that goes from water to gas, I think it's 561 calories at the small c. And that causes the tongue or the surface of the nose to cool. And then there's blood right behind that, blood in the tongue thing. If you cut your tongue, it's really bloody, right? If you cut your nose, right, it's a lot of blood. There's a huge amount of vasculature in there, all these arteries and veins, right? So that you cool then the blood that's just below the surface of the tongue and in the nose, and then that cools down your body, right? Oh. So panting is how animals cool. Or you can even watch a lizard. A lizard also does what's called gullar pumping. It'll actually, that's how it cools itself down. Watch a lizard will run, and it'll basically pant, and then it'll run again, and it'll pant, and it'll run again because it's prevent itself from overheating, right? Now, what we did is we have sweat glands. So most animals there are two kinds of glands, right? There's one's called apocrine glands. Those are the glands we have in our armpits and around our genitals, et cetera, or in our ears. They produce waxy, sort of fatty substances, right? There's the ones that smell, or earwax that protects our ear. So most mammals have those apocrine glands. Eccrine glands are watery glands, and most mammals have them just on their paws and their feet, right? Mm-hmm. So that they can, just think about when you wet your finger, you can turn a piece of page, right? It gives you more grip on something. Mm-hmm. So when you're trying to escape from a predator, sweating on your hands will help you run up that tree. If you're a mouse or something like that, a rodent. So most mammals have eccrine glands just on their palms. But in monkeys, they started to evolve having some sweat glands on their bodies, but not many. And so chimpanzees, monkeys have some eccrine glands on their bodies. But what we've done is we've increased that by an order of magnitude. We have like 10 times the number, 10 times the density of eccrine glands than monkeys and chimpanzees. And we lost our fur. And of course, fur prevents air from convection of air next to the skin. So when you sweat on your skin and you don't have fur, you can have evaporation of moisture, and then air takes that away quickly, so you can keep evaporating moisture, and then you can cool your body. So we've effectively turned our entire bodies into a tongue, essentially. And so we can dump amazing amounts of heat when we're physically active in hot environments. And that was obviously important for our ancestors when they're hunting, right? We have a huge advantage in the heat of the day because we can, not only we're good at running because of our legs and our muscles and our Achilles tendon and all these adaptations we have for running, but we also have this incredible thermoregulatory ability to dump heat, which the animal we're chasing does not have, and they'll die of heat stroke. But we don't know when that happened. And it's possible that our Australopith ancestors, before hunting started, because remember, they're two-legged creatures, right? And they're not very fast. So maybe in the middle of the day when it was really hot, that was the best time for them to go out and get food, because that's the time of day when the carnivores that would love to chase them, right? If I'm a carnivore and am I going to eat a gazelle or an Australopith, right? The Australopith is going to be half the speed of the gazelle. That's easy pickings, right? So I'm going to go for an Australopith. So maybe our early ancestors foraged in the middle of the day when it was really hot, so that because they were too slow to run away from carnivores, and maybe that was an adaptation. So the ability to dump heat effectively might have been really important for them. So it's possible, we just don't know, that sweating actually came before hunting. It's just simply, at this point, we don't, because skin doesn't preserve in the fossil record. We just don't yet know when that happened.
What about a big brain? Did that come before hunting, or is that a product of the fact that we started hunting?
It looks like more the latter, right? So Our chimpanzees have brains, a typical chimpanzee might have about a 400 cubic centimeter brain, like 400 grams. Think about it in grams, right? Typical human has a brain that's like 1,400 grams. So, really like 3 to 4 times the size of a chimpanzee's brain. For about 5 million years in our evolutionary history, so the earliest hominin is the term for a creature more closely related to us than a chimp, right? So the earliest hominins plus, these Australopiths like Lucy, they had brains that got up into the 500 gram range. Rarely, maybe sometimes 600, but not that much. Starting around 2 million years ago, brain size just starts to shoot up if you look on a graph, right? And that's, of course, around the time we started hunting. But it's really the time we have hunting and gathering. And so I think it's the whole system. It's not just meat, although meat must have been an important component of it. But the whole hunting and gathering system is really a way to get more energy, right? Because you're processing your food, so you're getting more energy because you're cooking your food or you're processing it in various ways. You're cooperating. You're getting new sources of food such as meat and marrow and brains and whatever. All of that together means that more energy is available, and when more energy is available, then there's less of a constraint on brain size because brains are expensive. Just right now, you and I were sitting, right? We're not really doing much of anything other than talking, but 1 out of every 5 of our breaths is to pay for our brain. Our brain is using 20% of our metabolism, right? And so to have a really big brain means you have to have a lot of energy available to you. And it's so most animals can't afford big brains because they don't have enough energy, right? With hunting and gathering, you get more energy. More energy means selection can now, the constraints on having a big brain are now released. And now you can get selection for a larger brain. So individuals with bigger brains might have had some advantage over individuals with smaller brains. Maybe they were better at doing this, that, or the other. And so you get selection for larger and larger brain sizes. And it really accelerates up until, it continues up until a few 100,000 years ago when essentially brains reached basically modern size.
And then you get fat because you have so much energy and you have such a big brain. It's
all about energy.
But that kind of makes sense, doesn't it? You store more energy and then we started to get fat?
Well, fat is really important for a number of reasons. And one of them is having a big brain. So, a human infant, when it's born, its brain is consuming half its metabolic energy. Mm-hmm. Like when a kid is born, 50% of the energy it's spending is just to pay for its brain. It's a brain on a little body, basically, right? And of course, you can't stop feeding a brain. Brains require energy constantly, right? Brains don't store energy. They need a constant supply of glucose or ketone bodies, which you can use when you don't have sugar available to you, right? You can get those from fats, right? So human infants are born unusually fat. A guy named Chris Kazawa showed that, we know that a human baby when it's born is about 15% body fat. Way more than any other species, right? And that brain, all that fat is really kind of like money in the bank to make sure that brain always has energy available to it. And furthermore, he had published a really cool paper a few years ago which showed that when an infant's brain is growing, right, in the first few years of life, when it's growing really fast, that's when its body fat levels are going down. And when it's storing a lot of fat, that's when its brain isn't growing very much. So there's a trade-off in energy between fat and brains as we're growing. So big brains and fat bodies are intimately connected.
So we want to make sure our babies are fat.
A fat baby is an essential, fundamental human adaptation. And the body fat that we have, a typical human has much more body fat than most animals. Most primates have about 4 or 5% body fat. Most mammals have about 4 or 5% body fat, whereas a skinny human has maybe 10 to 25% body fat, right? So that body fat is not only important for brains, but it's also important for our reproduction because a typical mother nursing, for example, right? Hunter-gatherers will nurse for about 3 years. Nursing is really expensive. It costs about 600 calories a day to produce breast milk. Imagine you're a hunter-gatherer and there's not a lot of food around, right? You're in what we call negative energy balance. You're not getting as much food in as you're spending, right? You can't just stop nursing. Your infant is still going to require that energy. So you draw down on your fat reserves, right? And so having all that fat which goes up and down and up and down from season to season. You store more fat in the good seasons, you use that up in the bad seasons. Those are fundamental adaptations to keep us physically active, to enable us to reproduce the way we do, to pay for our big brains. They're part of, that our kind of relatively high level of fat and our predisposition to store fat is fundamental to our species. We wouldn't be here if we didn't have all that fat.
And I guess this is why dieting is so hard.
Right, because, we never evolved to diet. We evolved to put that fat on. We did evolve, of course, to use it when we needed it, right? But we never evolved to get rid of fat. No, there was never, in an absence of obesity, there wouldn't be selection for that kind of physiological system to lose fat without needing it.
Because when we try and diet, it does feel like our body's somewhat against us. When I hear about like sugar cravings and, many people have told me that the reason why diets don't work is because your body's trying to basically defend the weight that you're at because that used to mean your survival.
That's right. We call that a starvation response, right? So when you go into negative energy balance, which is what a diet is, right? You're spending more energy than you're taking in. Your body goes into a starvation response. Your cortisol levels go up, for example, right? It's an emergency, right? Cortisol is our stress hormone. Stress doesn't cause cortisol to go up. Cortisol goes up when we are stressed, and it makes energy available to us. And one of the things that cortisol does is it makes us hungry, right? When you're really stressed at night, right? Studying for an exam of one of my students, right? They get, hunger, they get sugar cravings, right? Because their cortisol levels, because they're stressed, because I'm going to give an exam on the next day, goes up, and then they want energy, right? Cortisol also makes you store fat in visceral deposits. So belly fat, which is concerning, right? It's a useful kind of fat, right? Because the fat that we store in and around our abdomen is very hormone sensitive. It's got lots of blood vessels, so that fat is a great energy supply when you're physically active, right? When I went running around Central Park this morning, right, I was burning some of my belly fat. But when cortisol levels go up, that's like it also directs us to deposit fat in those stores, right? And the problem with those stores is that they're also very inflammatory. So when those fat cells get too large and they swell, they become dysfunctional and they cause inflammation. They cause chronic systemic inflammation, which is just ruinous for our health. It causes diabetes and Alzheimer's and heart disease, all kinds of diseases that pretty much every major disease that we're worried about, mismatched diseases that we often talk about, are many of them are inflammation related, and that's why people are concerned about excess adiposity, excess fat, because excess fat causes inflammation.
So that means that people that are more stressed are more likely to have belly fat. Correct.
Yes, that's true. So that's one of the reasons why stress is, a risk factor for so many diseases. Psychosocial stress it has pernicious effects, and that's why racism, discrimination, all those factors that can elevate stress, commuting, have negative health consequences because it causes our cortisol levels to go up. It causes us to put fat in the wrong places. It has cortisol also turns your immune system down. Cortisol has all kinds of negative effects when it's long-term and persistently high.
It's often been said that if you lose too much weight, for example, if a woman loses too much weight, then her menstrual cycle will stop. And I was thinking about this from an evolutionary perspective. And you were saying how, fat is essentially evidence of our survival. So in some ways, if that is true, then is that our body basically stopping our menstrual cycle to conserve energy? Basically, if you could think about it like our body saying to us, we don't have the energy to have kids right now.
You are absolutely right. So it's a little bit more complicated than that, but you basically got it right. So there's two things. First of all, fat is not just an energy store. Fat is also an organ, right? Fat produces hormones. Your fat produces a hormone called leptin, which affects appetite, but it also produces estrogen. So when women have very low levels of body fat, their estrogen levels decline, and they don't produce enough estrogen to have effective menstrual cycles. So they become what's called amenorrheic. Amenorrhea just a fancy medical term for loss of sort of normal cycling. It's been shown by many researchers, a former professor of mine, Peter Ellison, and there are other researchers around the world, a woman named Grażyna Jazienska in Poland, others have shown that, our bodies are incredibly sensitive to energy availability. For example, women who are dieting, they may have plenty of body fat, but when they're dieting, which means they're going to negative energy balance, levels of progesterone, which is a very important hormone for the menstrual cycle. Progesterone is produced in the second half of the menstrual cycle, and it maintains the uterine lining so that you can have implantation. Progesterone levels plummet. They go down by 50% during the luteal phase, that second half of the menstrual cycle, thereby decreasing their ability to conceive. Women who are very physically active, also there's a decrease in the amount of progesterone, again, during the second half of the menstrual cycle. And a flip way of thinking about it, though, is that because remember, what we evolved to do is to have as many offspring as possible. And so our bodies also, another way of thinking about this also is that whenever there's extra energy available, the body, it's an adaptation to say, hey, let's use that energy for reproduction. So let's increase estrogen levels. Let's increase progesterone levels so we can increase our fecundity, increase our fertility. So there's a bit of a
balancing act.
Yes, it's a bit of a balancing act. So obviously, exercise is not bad for women who are trying to conceive, and women who are sedentary and aren't exercising have high levels of estrogen and progesterone, and that's maybe one of the reasons why physical activity decreases the risk of breast cancer so much. So women who are physically active have like a 30 to 50% lower rate of breast cancer, and part of that has to do with the fact that their hormone levels are more normal, because sedentary women have abnormally high levels. But nonetheless, it's the important point from what you asked is that the body is incredibly sensitive to energy, right? And so it knows that when energy levels are low, when you're losing fat, this is not a good time to invest, because think about it. Pregnancy lasts 9 months. It's incredibly expensive. Then you're going to be spending months later nursing, which is also very expensive. Maybe this is not a good time to invest. Let's wait until times are better. Then you know that this is a better use of a better time to get pregnant. You can have a much more likely positive outcome.
I was thinking about what you were saying through the lens of stress as well, because stress releases cortisol, and if someone is incredibly stressed, I imagine they're going to have trouble with fertility as well. Probably for the same reason. I guess it's like a lion was running at you. This is not a good time to have a...
Cortisol, one of the things that cortisol does is it turns down everything that you don't need to do at that moment in time, right? Because we evolved to elevate cortisol acutely, for short bursts when the lion comes into the room, right? But not over very, very long periods of time. So, when the lion comes into the room, this is not a time to reproduce. It's not a time to spend energy on your immune system. It's not a time to do all kinds of stuff, right? Just run, right? Make energy available. But situations where you have persistently high levels of cortisol.
Chronic stress,
that's what we call a mismatch, right? Mismatches are conditions that for which our bodies did not evolve, right? These are novel environmental conditions for which we are inadequately or imperfectly adapted for, and that they cause the vast majority of the diseases and problems that we encounter today. And taking exams is a mismatch. Having discrimination, racism, poverty, these are and all those sorts of things that elevate our cortisol levels for long periods of time. Those are mismatches. In fact, the vast majority of the diseases that people have today, apart from some infectious diseases, but the vast majority even of infectious diseases are mismatches because they come from humans spending more time with animals, and a lot of the diseases that infectious diseases that we have actually are diseases that jumped over from the animal world to humans. Tuberculosis, for example, right? That's a disease that hunter-gatherers didn't get. It came after farming.
The vast majority of diseases.
I would say so, yeah. Heart disease. Look, when we look around the world and look at people who don't live in modern Western lifestyles, heart disease is rare to non-existent. There's a wonderful study of a group of people in the Amazon called the Chamane. These are horticulturalist foragers, right? There's like no evidence whatsoever of any coronary heart disease in these people. Some of the populations that we've studied, no increase in blood pressure. In fact, back in the 1970s, some of the first studies that were ever done on the health of hunter-gatherers found that 80-year-old hunter-gatherers in the Kalahari had the same blood pressure as 20-year-old hunter-gatherers in the Kalahari, and they compared them to English people and Londoners at the same time. And of course, by the time you're 70 or 80 in London, almost everybody's hypertensive, right? This is because of diet and physical activity and probably also stress. These are things that have changed in our modern world for which we are very poorly adapted.
No diabetes?
If it exists, nobody's diagnosed it. It's probably incredibly rare. But even a few generations ago, diabetes was rare. I mean, diabetes is the world's fastest growing disease. Where I work in Kenya, in the area around a city called Eldoret, when I first started working there, gosh, long time ago, you drive into the city and you'd be in Eldoret. Now, as you drive into the city, you pass by all these diabetes clinics. They weren't there before. That's because diabetes is rising in Africa at incredibly rapid rates, which, isn't that surprising because diabetes in places like the United States and England are incredibly common. About something like 12% of Americans have diabetes now.
You said that this mismatch is responsible for most diseases. Doesn't that therefore mean that I'm most likely to die from a mismatched disease in my life?
Yes.
Okay.
Yes. The vast majority of us in the Western world will die from a mismatched disease. The number one disease in the world today that kills more people than anything else is heart disease. And as far as we're heart disease kills at least about a third of us. Cancer is number 2. Cancers, of course, are an ancient disease, so not all cancers are mismatched disease, but many cancers are mismatches, right? Breast cancer, which is much more common in Western populations than in non-Western populations. But heart disease, is essentially, as far as we're concerned, non-existent until fairly recently.
And now it's killing about 33% of us. You said a third, right?
Yes.
That's crazy. It's so crazy.
That's the bad news, right? But the good news is because they're mismatched diseases, they're not inevitable, right? We shouldn't just say, all right, heart disease kills a third of us. Let's just, because the amazing thing about heart disease is that diet and exercise can prevent a large percentage, if not almost all of them, right? If people who live in environments where they don't eat obesogenic diets that make people overweight, diets that lead to metabolic syndrome, diets that are atherogenic, that cause atherosclerosis, right? People who are physically active, and stress is also an important plays a role in heart disease. Don't smoke, have vastly lower rates of heart disease to the extent that it's, this is a disease that doesn't have to exist.
You said you're writing a book about diet and food.
Yes.
Why?
The story of how the diets that we eat today and is actually a really fascinating story, but also because I think that if we take a more evolutionary approach to diet, we can, I think, do much better to thinking about help people make choices. I mean, one important point to make is that today, like when we finish this interview, I'm going to go home, and my wife and I are going to, and my daughter and my mother-in-law are going to try to decide what we're going to have for dinner tonight, right? And we can eat whatever we want, right? We can go to the supermarket and there's you name it, right? Here in New York, there really is, you name it, right? We can go out to restaurants. We can have Chinese or food or Japanese food or American food or French food, whatever, right? We have incredible choices to us. For most of human evolutionary history, people never chose what they ate ever, right? They ate what was available to them. And now with all this choice, comes bad choices, right? And so I would like to help people figure out how not only realize that these choices that we have to make we're not really evolved to do, but also how to better understand what those choices are and what the complexities are of them. Because there's no such thing as a free lunch, right? Every choice that you make has alternatives and alternative consequences. And I think people oversimplify diet. People come up with simple ideas. Just do this, just be a vegan, just be a this, just be a that. There are no perfect answers.
Do you think in some ways that our culture moved so much faster than our biology in a sense, because we're like super sedentary now. We just sit all day. We have these screens that bring us our food. The food is processed. And is this part of what's causing this sort of misalignment, all these mismatched diseases, as you call them, is?
Absolutely, because evolution by natural selection occurs really slowly, right? Every generation, people with genes that give them adaptations, they're better able to handle a particular environmental context, do better than the next generation. So slowly, generation by generation, you get change, right? And that's true for every animal, right? Mismatch is not unique to humans, right? As environments change, some animals are better adapted to that environment than other animals, and those animals are going to be more likely to pass those genes on to their offspring. So mismatches are part of a natural selection. Every species, as environments change, is subject to mismatch, or as they move into new environments. The difference with humans is that we have culture. And culture has caused an acceleration of environmental change, right? Think about, just today, right? I have now in my pocket a computer, right? That I didn't have a few, decades ago, right? We have internet and email and all kinds of things, right? Just the last few decades, the world has changed amazingly. Just think about the last few generations, the last few hundred years, the last few thousand years. So cultural evolution is so powerful and so rapid. It's so fast. It's so transformative that we have made our world so vastly and rapidly different that our bodies cannot possibly keep up in terms of our biology. It's this mismatch. It's this difference between evolutionary biological change and cultural change that has heightened the kinds of mismatches that we exist. And then guess what we do, right? So I'll give a very simple example, right? Until recently, nobody read, right? And nobody spent a lot of time indoors. And so myopia used to be extremely unusual, right?
What's that?
Myopia is being nearsighted.
Okay.
So if you go to, there's a famous study where they looked in Inuit populations, right, in Alaska, and they looked at grandparents and grandchildren. The grandparents all had perfect vision, and the grandchildren all need glasses, or at least a large percentage of, 30% of them, right? In various parts of the world, the number of people who are nearsighted has gone up. In some parts of the world, it's 50%. In America and England, it's probably about 30% of us need glasses. But this is all recent. In fact, the first study of this was done on the Queen's Guards. Or actually now they're the King's Guards, right? Mm-hmm. So they have the bearskin hats. I don't know what kind of fur it is on their head. Anyway, they're the ones who stand in front of Buckingham Palace, right? There was a study done in the early 1800s which showed that it was the officers who had a higher percentage, like a large number of the officers had to wear glasses, but the foot soldiers were all fine. And there was something about it, right, that about the officers, and then people started studying them around the world, and then initially it was thought to be reading, and now we know from more careful studies that's really spending a lot of time indoors when you're young that causes myopia. So we never evolved to do that, right? So we're more prone to myopia, but it's not a big deal because guess what? We just go to the optician and we get glasses and we can deal with it, and doesn't really have any major effect on our health or our longevity, our ability to find a mate, etc. We all do just fine.
Can we undo it?
Well, here's the thing. What we're doing myopia, you can get LASIK surgery, and there are some things you can do, very expensive. Most people can't afford it, right? But the point is that we're treating the symptom. When you get glasses, you're treating the symptom, not the cause, right? Mm-hmm. But it's okay, right? Because it's just glasses, right? The problem is that for many mismatched diseases, right, when we're treating the symptoms rather than the causes, right? So cancer, right, or many forms of heart disease, right? You don't see a doctor in our medical system until you get sick, right? And then you get pills to lower your blood pressure and pills to lower your cholesterol, et cetera. But these aren't some of them can be preventative, but to a large extent, most of medical treatments are treating the symptoms of diseases after they occur. And of course, we should do that. We should alleviate pain. We should alleviate suffering. We should try to decrease people from dying from all kinds of diseases. But wouldn't it be better if we actually prevented those diseases in the first place, right? We would have a much more effective medical system. So what we're causing, in my opinion, a kind of a new form of evolution. I call this disevolution, whereby we're treating the symptoms of mismatched diseases, thereby enabling those diseases to remain prevalent, right? And in some cases get worse because we can now cope with them, right? So people now get diabetes, we give them metformin or whatever, various kinds of drugs. They get heart disease, we give them various pills to kind of keep them going. They get myopia, we give them glasses. All of these are things we should do, but wouldn't it be better if we prevented people from getting heart disease in the first place, right?
Because this is one of the big questions I always have with evolution, and when we're talking about our evolutionary history, is are we still evolving? And from what you said there, it sounds like we, in a way we are, but it doesn't sound good. It sounds, as you say, de-evolution. Sounds like we're in some ways... Disevolution.
Yeah. I mean, there is a little bit of selection going on. I mean, you can't stop selection. It's like gravity. It happens, but it's slow.
What we eat and how we eat, I think it was James Nestor that said, the way we chew impacts what our face looks like when we become adults. So if a baby's chewing lots of soft foods, when they grow up, they're going to have like a small jaw.
Yeah, that's research I did, actually.
Oh, yes. Really? I think he cited you. Yeah.
So how your chewing affects the shape of your, how your jaw grows. And so it is true that we have smaller jaws today than we used to. The good news is it's not that bad, right? It doesn't really cause that much. Maybe your teeth are more likely to have malocclusions, et cetera. But we can go to the orthodontist and have our third molars extracted, et cetera. I mean, we can cope with that, right? It's not that's not the worst thing, right? Of course, he thinks that it causes us to breathe through our mouths and all that sort of stuff, but it's not the kind of disastrous sort of mismatch that occurs from, say, well, this is controversial, but the evidence, the vast majority of the evidence suggests that if you eat a lot of sugar and you eat a lot of saturated fat, you're more likely to get heart disease. You're more likely to get plaques in your arteries, right? If you aren't physically active, do exercise or physical activity, your blood vessels start stiffening and you start becoming hypertensive, right? These are all aspects of our environment that we have the potential to control better and to prevent disease.
Do you think we've got into a bit of a bad habit as a society of just throwing a pill at the problem?
Yes. I mean, that's the fundamental argument of making about disevolution, that it's expedient to treat the symptoms of a problem rather than its cause.
What's the problem with that?
Well, because a number of reasons. One is isn't the best disease is the one that you never get in the first place. So we can keep people alive once they get heart disease. We can keep people alive once they get arthritis. We can keep people alive once they get all kinds of diseases, but their quality of life goes down. And of course, we pay for it. We pay for it out the nose, right? It's something like 70, 80% of the time when somebody goes into a doctor's office, that's for a preventable disease. 70, 80% of the time, right? That's an astonishing amount of money that we spend in our medical system on essentially mismatched diseases. Mm-hmm. It's bankrupting us, but it's also causing misery, and it differentially affects people of low income and people who suffer from discrimination. I mean, look in the United States, right? Who gets the chance to exercise and eat, fresh vegetables and, high quality foods and non-processed foods? It's wealthy people, right? So it's just unfair and unjust.
You mentioned cancer. In what way and how do we know that if that's a mismatch disease?
Well, cancer is not completely a mismatch disease. I mean, all species that are multicellular get cancer. Cancer is essentially a disease of evolution going wrong, right? Natural selection going wrong, right? So instead of, when you have many different kinds of cells in your body, when a cell becomes essentially selfish and starts to outcompete other cells because of mutations it gets, that's a cancer, right? So cancer is an outcome of multicellularity. Dinosaurs got cancer, right? We have evidence for bone cancer in dinosaurs. So we're never going to get rid of cancer completely. But we also know that cancer is very much a disease of energy, right? When people move to high energy environments, they're much more likely to get cancer.
More food, eating more.
More food. Physical inactivity is a major risk factor for cancer. Insulin, for example, high levels of insulin. Insulin, promotes anything that promotes mitogenesis, which is mutation, cells to divide, is going to increase rates of cancer. Also, anything that increases the rate of A lot of the cells that could get cancer are cells in our bodies that interact with the outside world. So our lungs, our guts, our colons, where things from the outside world come into contact with them. Skin, exactly. Those are cells that often get cancer. So when we have carcinogenous, poisonous, toxic compounds in our environment, those can elevate levels of cancer. So smoking, car pollution, et cetera, those can cause cancer. But also having lots of energy. So we talked earlier about when women are physically inactive, their hormone levels shoot up, right? Because the body says, more energy, let's spend it on reproduction, right? And there's a trade-off there. The higher levels of estrogen and progesterone increase the rate of breast cancers that occur because they cause more turnover in those cells in breast tissue, and that's why those cancer rates are higher. So there's famous studies which show that you look at women from Bangladesh who live in Bangladesh, women from Bangladesh who move to England, or Bangladeshi women who are born in England and live in England. No matter how you look at it, Bangladeshi women who move to England, their cancer rates go way up. The difference, a major difference, is energy. The diet that they have, the physical activity levels they have.
They're eating more, they put more weight.
Cancer rates just shoot up. So if you actually plot GDP of countries against cancer rates, it's almost nearly straight line. The richer the country, the higher the rate of cancer.
What about hunter-gatherer women? Did they have less ovarian cancer?
That's a hard thing to measure because diagnosing cancer requires some sophisticated technology. And to my knowledge, nobody's ever done careful studies of cancer rates among hunter-gatherers. But most of us are pretty convinced that cancer rates are much, much, much lower among hunter-gatherers. But again, also the population sizes are tiny, so you can't really get very large samples.
The amount of menstrual cycles you have
is a major factor, right? So I hope I get the numbers right. Typical woman today who goes through her entire reproductive lifespan will have something like 500 menstrual cycles because of birth control and smaller families.
It says 350 to 400 in your book.
Is that what it says? Yeah. Okay, thank you. Okay. It's in the hundreds, right?
Yeah.
Typical hunter-gatherer is going to have something like 50.
50?
Yeah. In her entire life.
Wow.
And every time you go through a menstrual cycle, your body is being exposed to high levels of these hormones, right? Birth control and sort of modern family planning, which, I'm not obviously opposed to it, but it is another factor that has probably elevated rates of breast cancer.
I never knew that. I never knew that having more cycles reduced your...
Sure, because every cycle involves surges of hormones. That's what causes the cycle. First, you have an estrogen surge, then you have a progesterone and an estrogen surge.
Of course.
That's what happens across the menstrual cycle.
And hunter-gatherer women would have been pregnant more often, more of their life?
Well, yeah, a typical, what we call a natural fertility population, a population that doesn't use birth control. Women are most of the time pregnant or nursing, and they go through short periods when they are doing neither and then get pregnant again. So the number of, and you don't, of course, have menstrual cycles when you're pregnant, and you generally don't have menstrual cycles when you're nursing until, again, it's your energy levels. So because nursing costs so much energy, that high energy demand of nursing suppresses ovarian function. So nursing women are often amenorrheic. They're not cycling.
And that's not just ovarian cancer, that's breast cancer as well.
It's any cells that are sensitive to estrogen and progesterone. Those are the cancer. Those particular kinds of. So often when you measure breast cancer, you talk about whether the cells are estrogen or progesterone sensitive.
I wanted to talk about how our body stores energy, because I think that in part answers a lot of these questions around the things we're discussing about weight loss, about diet, about all those things we've talked about previously. I have a very loose understanding of this. So please enlighten me. But I did go keto for 8 weeks and I lost so much weight. It's pretty crazy. It bounced straight back, of course.
Of course.
Yeah.
Because you mostly lost water.
Oh, really?
Yeah. That's one of the problems with many diets. So fat is a wonderful molecule, right? We tend to demonize it, but fat is life, right? Fat is a really important molecule. So a fat is a fat molecule has a backbone of something called glycerin, right? It's a 3-carbon molecule. There's a carbon, 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 and there's little hydrogen sticking off. And to each one of those carbons is a chain, sticks off a chain of what's called a fatty acid. So they're called triglycerides. There are 3 fatty acids on each glycerin. And there are different kinds of fatty acids. Like there are saturated fatty acids and unsaturated fatty acids. We can talk about all those, whatever. But the point is that each fatty acid stores a huge amount of energy because those long chains of carbon, what our body does is it cleaves those carbons into smaller units and we get energy from the bonds between those carbons. That's basically what our mitochondria are doing, right? So fatty acids, fats in general, store a huge amount of energy. They store twice as much energy as carbohydrates per unit mass. So what we do is we eat foods that have fat in them, or we eat carbohydrates and our livers convert them quickly to fats. It's easy, right? So that's why, fat-free diets don't prevent people from being fat, right? Often with the help of insulin, but it's not the only hormone involved. We want to store those. If you're not burning them, right? Our body can either burn them or store them. So if we're not burning them, i.e. we're running or gesticulating, talking, etc., we're going to store them, and we store them in special cells called adipocytes. Those are the fat-storing cells, and our bodies have billions of them. You're born with billions of these, but you only have so many adipocytes. You get them when you're young, when you're born, and that's it. That's the number of adipocytes you have for the rest of your life. And so those adipocytes, so insulin, for example, helps potentiate the movement of triglycerides, right? Which you want to break down, and then you transport them into the fat cell, and then you reassemble those fats in the fat cell, the glycerins and the fatty acids. You reassemble them in the fat cell, and they swell like a balloon. So every little fat cell in your body is like a little balloon filled with fat, and it's there to be used. And then there are hormones which then help us retrieve that fat when we need it, right? When we're running a marathon or just sitting around talking and without having had lunch for a while or whatever. And so, we store fat, we then burn fat, we store fat, we burn fat, we store fat, we burn fat, et cetera. And that's normal, right? And as we talked about earlier in this conversation, humans evolved to have an unusually high level of fat. So a typical hunter-gatherer male will have about 10 to 15% body fat. Typical hunter female will have about 15 to 25% body fat. That's normal, sort of skinny human being. That's way more than most mammals, right?
So women had more?
Women have more, right. So women have a higher percentage of body fat, although actually women tend to be smaller bodied. So the total amount of fat that men and women store is about the same. Mm-hmm. Women, of course, if you think about it, because they're the ones who have to pay for reproduction directly, either during pregnancy or nursing, that fat is especially important for reproduction, right? Mm. So what happens is that that fat is there, and it's like a bank account, right? It's energy that we store and energy that we use. And we store it in different places. Most of the fat that we store is what we call subcutaneous, so underneath the skin, subcutaneous. But we also store fat that we call ectopic. That's outside of where it should be. Some of that fat is, and a lot of that ectopic fat is, some of that's in our liver. We call that, so people have so normal livers have just a little bit of fat in them. But if you have too much fat in your liver starts to malfunction. It's called non-alcoholic fatty liver syndrome. You can have fat around your kidneys. That's what suet is, right? But too much fat around your kidneys, again, causes problems. Fat around your heart, so all that fat in your abdomen, that we call that visceral fat. Viscera means guts, right? So that gut fat is very problematic, and because when those fat cells get too big, so if you store a lot of fat beyond those sort of normal levels, as the fat cells get bigger and bigger and bigger, just like any balloon, they start to rupture. So, if you overfill a water balloon, it's going to break. If you overfill an adipocyte, it's also going to start break. And when it starts to break, it attracts the immune system. And the immune system comes in, white blood cells come, right? They think something's wrong. We have damage here. And they start to produce molecules that trigger a system-wide immune response, right? And the fat cells themselves also will trigger an immune response. The fat cells can produce the same kinds of molecules that our white blood cells produce. So the white blood cells produce molecules called cytokines. Cyto for cell, right? Kine for enzymes that do something, right? And so the ones that fat cells produce, we call them adipokines. And like one adipokine that it produces is a TGF alpha, right? You may have heard of. Mm-hmm. And that turns on it's like turns up the dial on your inflammatory system, right? And it goes everywhere in your body, and you start getting inflammation, right? And that inflammation, for example, if you have inflammation in your blood vessels, then that inflammation can help cause plaques to form in your arteries. If that inflammation occurs in your brain, those can cause plaques in your brain that can cause Alzheimer's. If that inflammation affects receptor cells on muscles, et cetera, that can cause insulin resistance, which can cause diabetes, and the list goes on, right? So that chronic inflammation, which can be caused by too many fat cells that are overpacked, essentially, is why too much fat can cause health problems.
The keto diet and fasting, someone said to me the other day that keto is basically a form of fasting in a way. And how do they help the body? Because people are pretty crazy and pretty keen on both fasting at the moment, but also the ketogenic diet.
Well, fasting is when you go into negative energy balance, right?
Which is how we spent most of our sort of evolutionary history, right?
Well, how you spend part of every day, right? We eat. After you eat, you're in positive energy balance. Mm-hmm. And then in between meals, your energy balance goes down, right? Now you're burning now energy that you've stored. When you're asleep, you're in negative energy balance. So fasting is just a prolonged state of negative energy balance, right?
Does that mean that it would reduce my chance of getting cancer?
Could do. People are hoping that's the case. I don't know how good the data are for intermittent fasting.
Because if the surplus in energy causes cancer, then me being in that negative energy balance presumably will reduce my chances of getting these.
Right, but then you have to go back into positive energy balance at some point too, right? You can't keep up negative energy balance. So intermittent fasting isn't necessarily a way to lose weight if you eventually, replace those calories, right? So here's a hypothesis, right, to which I cannot prove, but I think that when you exercise, right, you're also going to negative energy balance because you're burning energy. You're not eating while you're exercising. At least most people aren't, right? And your body's turning on all kinds of mechanisms to cope with that negative energy balance. You're turning on all kinds of repair and maintenance mechanisms. When you go through intermittent fasting, you're basically doing the same thing but less acutely. It's a more gradual level, and if you look at the genes that are turned on by exercise, and the genes that are turned on by intermittent fasting, many of them are very much the same. And I think it's because you're basically turning on genes that are responding to that negative energy balance. But I would argue that you're going to get more of a bang for your buck by exercising than just going through intermittent fasting.
Or both.
Well,
is that a bit too much?
Yeah, I mean, intermittent fasting might be a kind of a easy way to get some of the benefits of exercise without exercising. It might be. I mean, obviously there's nothing necessarily wrong with intermittent fasting, but I'm not sure that it has some of the huge benefits that people claim. Now, keto diets are a little different, right? So keto diets are when you're basically avoiding any carbohydrates. And carbohydrates, the basic building block of most sugars is glucose, right? Mm-hmm. Glucose is the sort of a simple form of sugar that are basically in starches. There's some other sugars. Fructose is also, which is the kind of the sweet one. But when you basically stop taking in glucose, right, you're now basically taking in only fats. And so instead of using glucose to fuel your brain and other cells in your body, you're now using what's called ketone bodies. These are essentially, remember we talked about how when you break those fats down into small little units, those are ketone bodies. They can be used as energy, but they're more of a kind of a backup energy source for our bodies than the primary energy source. So we use them. Our bodies tend to use them when we don't have glucose available to us.
And does that mean the same sort of repair and restore mechanism kicks in? Potentially?
No, I don't think so. Because that's not negative energy balance. You're just using an alternative fuel in this particular point.
Because a lot of doctors have sort of prescribed a keto diet for people that have like epileptic seizures.
Right. And I don't think anybody knows, I'm not a neurologist, but I don't think anybody knows why high ketone diets are so beneficial for epilepsy. But it could be that they do, and I just don't know it. It's not my subject. But anyway, there's there's a thought that if you just, essentially keep your insulin levels low and rely on ketone bodies instead of glucose, you can, do all kinds of miraculous things. For weight loss, if you look at the data, yes, it does tend to lead to rapid short-term weight loss, but the data don't show it is very effective as a long-term weight loss strategy. And I think your example, your own anecdotal account is sort of typical.
Are we too coddled? Are we coddling our kids too much and coddling ourselves too much? And is that causing some of these mismatched diseases?
Well, I'm not a psychiatrist or a psychologist, so
physically coddled.
Oh, physically coddled.
Stopping kids from doing anything that might hurt them, or the risk aversion and.
Yeah, I think so. Yeah, I mean,
the comfort industry.
Absolutely. I mean, I have a whole chapter in my book on comfort, right? We have this idea that comfort is somehow good for you. Like, where does that come from, right? Comfort is nice, but I mean, who wouldn't rather be in business class than in economy, right? But is a comfortable shoe better for you, right? Is sitting in a chair better for you than walking around or standing? Is it better to take the stairs or take the lift or the elevator? So comfort isn't necessarily good for us, but we now want to live in a world where we're able to have incredible levels of comfort, and it's definitely not doing us some good because kids need to run around. I mean, every kid needs a good hour of physical activity a day to build a healthy skeletal system and to, for all the other benefits that come from physical activity. So preventing our kids from running around and doing physical activity is definitely a problem.
Is there any evidence that our kids are getting sort of physically weaker or physically?
Oh, absolutely. Absolutely. I mean, we have data in the United States. I mean, we have this thing called the Presidential Fitness Test, right? That was started, I think maybe it was Kennedy started. Some president a long time ago started it. So we have decades worth of data, and kids today are less fit. Absolutely. Ask any Army recruiter, they'll tell you that fewer and fewer Army recruits are physically fit and able to be.
What about strong in terms of bones and our skeletal structures?
Yeah, I mean, the rates of osteoporosis are going up, and one of the reasons for that is that loading our skeleton when we're growing up causes the skeleton to accrue mass, to grow bone. If you don't exercise, right, and especially weight-bearing forms of exercise, you don't grow as much skeleton, and then when you hit, normally people stop adding bone around 25 to 30, right? So I don't know how old you are, but
31.
All right, so that's it. You have no more bone to add, and for the rest of your life, you're going to start losing bone, right?
Sugar.
But fortunately, you look like a reasonably fit person who was very physically active, so you probably built up enough bone. So having a high level of bone when you're 25 to 30, as you lose bone, that's going to protect you from falling below that threshold that's going to give you osteoporosis. But if you aren't physically active when you're young, you have less bone to start with, you're still lose bone, and you're going to be much more likely to fall below that threshold. You're much more likely to get osteoporosis, and rates of osteoporosis are rising. Again, it's another one of these mismatched diseases that's rising radically throughout the world. Exercise also helps prevent bone loss because it suppresses the cells that essentially cause our bones to start being resorbed. So it's kind of a double whammy. Not enough exercise when you're young, you have less peak bone mass. Not enough exercise when you stay old, your bones are going to lose mass at a more rapid rate.
I was reading in your book that teen tennis players can become 40% thicker and stronger when they become older because they were using
in the arm that they use. Yeah. So
really?
So when you play tennis, right, the arm that you use, which is whacking the ball, that's getting more loading than the arm that you simply use to throw the ball in the air. So there's an asymmetry. So the humerus, the upper arm bone of tennis players, can be like 40% thicker in the arm that they use to whack a tennis racket. Just the bone, yeah. It's a beautiful experiment, natural experiment in our body to show the importance of loading. That loading causes your skeleton to respond, because our skeletons are like other tissues in our bodies respond to demand, right? We match capacity to demand. If you don't demand something of a tissue, it's not going to grow the capacity because otherwise it's going to be wasting energy, right?
I know that about muscles. I knew that muscles grow and expand, but I didn't think I had any say in the development of my bones.
Absolutely. Yeah. Loading your bones is one of the factors that we talked about it earlier. That's why people who eat harder food, that's less processed, grow larger jaws, right? Our jaws have shrunk by about 6%, we showed, by about 6% since we started processing all our food, because we're just loading our jaws less, right? That's another example.
Is there a consequence to this?
Well, so one consequence is increased rates of malocclusion, right? There's just not enough room for our teeth to fit into our jaws. So now we have to go to the orthodontist to get our wisdom teeth removed because there's not enough space for them.
Because, okay, so if I just get my kid chewing hard food from the jump, then his wisdom teeth will be fine.
It might be the case, yeah. So the experiment I'd like to see somebody do, of course it's unethical, right? It would be to randomize two groups of kids, have one group of kids basically chew really hard resinous gum for like all their childhood, right? Because you're not going to get them to eat like, unprocessed hunter-gatherer food, right? But basically have them chew gum all the time. And then compare them to, say, their twins who don't chew that much gum, and let's see who see how much of an effect it has on their jaw growth.
Puberty, the age in which women go through puberty has changed quite significantly.
Yeah,
and I couldn't figure out why.
It's energy again, right? It's about energy. Remember, life is about energy, taking in energy and using that to reproduce. So how much energy you have when you're growing up affects the rate at which you grow and the rate and your ability to switch from growth to reproduction. So we have data, for example, from France. There's good data from hundreds of years in France. I'm not sure why the French have such good longitudinal data. Maybe it's because of Napoleonic army or whatever. But we can show that 200 years ago, French girls were tending to go through puberty. They would start their menstrual, they went through what we call menarche when they start menstruating around the age of 16. Today it's around 12 and a half, right? And that's because of more energy. We see that in the area of Kenya where we do field work, right? We're looking at the same population, Kalenjin-speaking people, and in the rural areas where, they have hard lives, right? They're working all day long. There's no machines. There's no electricity. There's not a huge amount of food. Girls go through menarche about 2 years later than in the urban area, just 50 kilometers away, where there's more food, there's more energy, there's more Coca-Cola, there's more whatever. And we call that the secular trend, right? So that girls are maturing earlier, they can reproduce earlier, because again, what does natural selection want you to do? It wants you to take in energy and use it to reproduce. That's what we're adapted for. So if you have more energy, we're evolved to do it earlier.
Every time I have these conversations, I realize that I'm sat in a chair for a living for sometimes 3 hours at a time. Today, I've been sat in this chair for about 7 hours. And I go, fuck, this is not going to be good for me over the long term. If I do this podcast for the next 10 years, maybe I should just wrap it in here. I mean, it's been a good run. Does it matter that I'm spending so much time sitting down? Is there any evidence that this is going to, have an adverse effect?
Well, so the evidence is that people who sit more, it can be an issue. But there's two issues. One is that if you look at the epidemiological data, what really matters is leisure time sitting versus work time sitting. So people who sit a lot at work, but then also sit a lot in their leisure time when they're not at work, they're the ones who run way more risk of disease than people who are just sitting a lot at work. So that's one issue, right? So I think you're probably okay, because I can tell you, I know that you're obviously very physically active, you work out, et cetera. That's going to help be very protective. But the other issue, and I think we talked about in the previous interview, was sitting bout. So how long you sit for a particular period is also very important. So we should be getting up every 20 minutes. You're going to be interviewing Dave Reichland in a few days. So Dave Reichland published one of my favorite papers ever, who showed that the Hadza sit just as much as Westerners. They sit about 10 hours a day. But they get up all the time. If you're in a Hadza camp, there's babies running around. They get up to get the babies. They're getting around to tend the fire. They're getting up all the time. Nobody sits for a few hours and just like does what you and I are doing. And when you get up, you're kind of turning on the metabolism of your body. You're turning on your muscles. It's like turning on the car engine, right? You're kind of awakening all kinds of metabolic processes. And that seems to have a huge amount of benefit. So the key is, if you're going to sit, get up a lot. Right? Get up, go pee, make a cup of tea, whatever, interrupt your sitting a lot.
I'll be right back.
And of course, if you're going to sit at work, make sure that you're not spending, sitting in your car to get to work isn't good. And then you go home and you sit on the couch and watch television. That's not good. So make sure that those non-work periods of time don't involve too much sitting.
Is that why we've got so many of these random pains, joint pains? We were talking about, you said back pain is what did you say?
It's the number one medical complaint in the world. Yeah, back pain.
And that surely is because of the way we've designed our chairs and our lives.
Well, a part of that is also just back strength. So we I'm sitting in this lovely, comfortable chair here and I'm resting my back against it. I don't have to use any of the back muscles, right? So we develop weak backs that don't have any endurance. So they're quickly fatigable, right? So, and actually the best predictor of whether somebody gets back pain is how strong their backs are. And not just like acute strength, like from doing, like one thing. It's how much endurance their back muscles have. Because just think about it, like, I don't know about you, but like every once in a while I get back pain, right? I bend over to pick up a pencil or something like that. And I think, it was picking up the pencil, right? But that's just the straw that literally broke the camel's back, right? It's really the fact that it just happened to be the event that triggered it. But it's when my back is weak, right, that I'm just more likely to do something a little bit weird and then trigger something that causes a spasm, right? But having strong back muscles is the way to prevent back pain.
If someone's just heard everything you've said about these mismatched diseases, there's a lot to take in. There's a lot of different mismatched diseases. You said that if you're going to die from anything, it's basically going to be one of these mismatched diseases. Is there a conclusion? Is there an actionable conclusion about something maybe that I can change or do today? Or is there a philosophy you can lend me that is going to reduce my chances of getting one of these mismatched diseases? Just like a broader philosophy towards a life.
Yes. I think there's two. The first is that understanding why we get particular kinds of mismatches helps us make decisions about how to use our bodies, right? What to eat, how to be physically active, how to sit. I mean, all the things that we've been talking about result in action items, right? Let's get up more often, right? Let's not eat sugary, fatty foods so often, right? Let's try to avoid psychosocial stress, which is, you can't just, wave a magic wand and do that. That's a hard one. But we think that our life is normal. We think it's normal to live the kinds of, everybody thinks their life is normal, right? We think the foods that we eat are normal, the kinds of physical activities that we do are normal, the clothes that we wear, the shoes that we wear are normal.
Cars,
all of that, right? But from an evolutionary perspective, they're not normal. That doesn't mean they're not good or that they're necessarily bad, right? But it gives us a chance to pause and think and ask, do we have to live with this, right? Or how can we modify the way we use cars and taxis and shoes? And, we don't have to get rid of shoes, but maybe we'd be better off with more minimal shoes, especially for our kids. Maybe we'd be better off without, processed foods that have all the fiber, removed and all that, that fat and sugar added and all kinds of other crap, right? Again, let's not engage in a paleo fantasy and pretend that hunter-gatherers don't get sick or that, hunter-gatherer, if eating like a hunter-gatherer will make you, absolutely healthy. That's not the way it works. But we have information that we can learn from our evolutionary history that helps us make better decisions. So that's point one. And point two is that we need to be really aware of this vicious cycle that we've created in our modern world, whereby treating the symptoms of these mismatched diseases are actually driving forward the system and making things worse. There's a reason that heart disease is going up in the world. There's a reason that diabetes is going up in the world. There's a reason that myopia is going up in the world, right? It's because we're creating novel environments for which our bodies are poorly or inadequately adapted. And then instead of preventing those causes, we're simply, when we can, treating the symptoms. And so we're not stopping that, the fundamental problem from occurring. And thinking about it that way from a kind of modern sort of cultural evolutionary perspective, it's not a form of natural selection. It's a kind of cultural evolution that's going on, but it's cultural evolution that's affecting our bodies. And thinking about that vicious cycle that we've created can help us stop the vicious cycle.
As you'll know if you've listened to this podcast before, I'm an investor in a company called Huel. I'm on their board and they sponsor this podcast. Daily Greens, which is this powder I have in front of me for those of you that can see, that gives you some incredible health benefits. Your energy, your concentration, your immunity is now available in the UK. For the 91 vitamins and minerals you get from it, the adaptogens, the Daily Green probiotics that are within this blend, and for the last year or so, all of you on this podcast that have DM'd me about this product have asked when it will be coming to the UK. It's now here. If you're someone that wants to get more greens into your diet, then I highly recommend giving it a go. Not only is it good for you, but it tastes good. Win-win. The product was so popular in the US that it sold out over and over again. And I think that's what's going to happen here in the UK. So get your hands on it now. Just give it a try. Take a picture, tag me, DM me, let me know what you think of it. Because I think it's going to become one of your staple products. If you're someone that's looking for a greens product in your life, then I really believe that this will probably become your staple as it has become mine. Thank you so much, Daniel. As you were speaking, I was just thinking about something we haven't discussed, but that is front of mind for me at the moment, which is the cosmetic products that are in my life. I spray all this deodorant on my pores and I put all these chemicals on me, and there's a whole industry that are telling you to rub these creams into your face and all of this stuff, and alcohol in your mouth with mouthwash. And over the last 3 months since we last saw each other, I have really started to rethink about all these chemicals that I just assumed we're all meant to like throw down our mouths up our nose, and you know what I'm saying?
Yeah.
Is there anything that you've learned, that any advice I need on that stuff?
Just be skeptical.
Skeptical. Okay.
I mean, look, there's an entire world of people out there who are trying to sell us stuff, right? And if you're particularly like you're clearly interested in how to live your life better, right? So I think you're especially vulnerable to people with the latest big idea, the latest new product, because you're a seeker, right? You're looking for this stuff, right? So they've got you. You're in their target, right? And you're I think more vulnerable. So I think being skeptical. Now, that doesn't mean that all products are bad for you, but probably most of them are, right? Or at least they're not going to do much benefit, and there could be unintended consequences. Everything has trade-offs, right? When you take some mouthwash, right, and kill the bacteria in your mouth, most of the bacteria they're killing probably are useful, right? Your microbiome, you have an oral microbiome. A lot of that's good for you, right? And it may have a short-term benefit of maybe making your breath feel a little bit better, but it may have a long-term cost. I don't know. I'm not an expert on the oral microbiome. Well,
I've thrown it out anyway, because that was one of the things I looked at. I thought, okay, so I've quit alcohol. I don't drink anymore. But this mouthwash that I'm having is got all this alcohol in, and I'm throwing it in my mouth every day, which is killing all the good bugs in my gut microbiome. And also even on our hands, because of COVID, we got into this culture of sanitizing all the bugs off our hands. And it was quite scary because I think, again, through this lens of like, what is the more natural way to live? And this constant sanitizing of our hands and our children's hands and this fear of bugs. My girlfriend comes back from the gym and she rushes into the house and lathers on all this antibiotic because she's been touching things that other people have been touching.
When I go to the gym, I do that too. But yes.
Me too.
But I mean, yeah. But look, you've heard of the hygiene hypothesis, right? You have the same immune system. I have the same immune system as our great-great-great-great-great-grandparents, right? Our immune systems, we all have these really amazing immune systems that evolved to protect us from all those germs and worms out there, right? This is something I talk about in the book too. Now, in this highly sanitized world, I still have the same immune system, but now it's like doesn't have anything to do, right? The analogy I use is it's like a bunch of teenagers hanging out on the corner with nothing to do. It's much more likely to get into trouble, right? And so people who grow up, especially in more sanitized environments with dishwashers, without pets, without animals, et cetera, are much more likely to develop allergies and various kinds of autoimmune diseases because their immune systems are no longer busy defending them from the normal pathogens that are out there in the world that we evolved to live in. And now we still have the same immune system, and now they're like those teenagers on the corner. They have nothing to do, and that increases the probability that they start to attack us. So that's why peanut allergies and various kinds of allergies and milk allergies and whatever, all these allergies are up on the rise because our immune systems are so unchallenged. They basically end up accidentally attacking us because they have no pathogens to deal with. That's true of a wide range of autoimmune diseases. And so being ultra sterile environments, we think it's like great, but actually, and during a pandemic, it can actually prevent you from getting an infectious disease, but it also has costs. And it'll be interesting to see all those kids who were born during the pandemic who didn't interact with other kids that much, in nursery school or play school or whatever, who are wearing masks all the time, wearing getting all those creams, those antibiotic creams, stuff. They might be more likely to get autoimmune diseases. We'll see as they grow up what happens to them.
Daniel, thank you so much. All of your books are absolutely fascinating. It's so bloody annoying because I could just talk to you forever. They're so brilliant, all of the books. Absolutely brilliant. And I had so many calls after our last conversation, which I think has almost got 10 million downloads, which is crazy because it feels like it was a couple of weeks ago, from friends of mine. I got a particularly hilarious call from a lady called Davina McCall, who is, she's been a TV presenter in the UK. She's one of the most famous people on TV in the UK for 25 years. And she called me at 7 a.m., right? And she calls me at 7 a.m. She goes, Stephen, I've just listened to the podcast with Daniel Lieberman. She goes, I'm running. she was like, get out of my way. She's getting people out of her way and she's running down the street.
Well, I'm very honored. Thank you.
But I had so many phone calls like that and so many conversations like that because of that conversation. And this book is just, the story of the human body. It is essential reading, and as I've heard, it's being used in schools and education institutions. So I do hope that you continue to evolve and update the book with new science as and when it comes, because it's such an important book. Thank you again for the generosity of giving me your time. It's a huge, huge honor. And I say that, I don't say that lightly. We have a closing tradition on this podcast where the last guest leaves a question for the next guest. You know the tradition. Okay. The question left for you is, for what would you be willing to die today?
That's a very hard one. I mean, obviously, you know, I think we all think about that occasionally, right? I would, if it need be, I think for the people I really love and care about, right? For my daughter, my wife. And I think I would certainly be willing to risk dying, you know, if it really had an enormous benefit for humankind. It would not be an easy decision to make. And I've never been put into that position, so it's all theoretical. I think you wouldn't know the answer until you had to make that decision at the moment.
Would you die for an idea?
I don't think so, but I don't know.
Interesting.
But ideas can be powerful and important.
Daniel, thank you.
That's a tough one.
It's really tough. And I'm just going to give it away a little bit here, but this is part of what we were discussing with the previous guest that was on the show. And he asked me this question. He asked me what I would die for and would I die for an idea, etc. And so I said I would die for my siblings and my partner, my romantic partner. For some reason, I said I wouldn't die for my parents, but I think it's purely because I think it makes more sense for me to reproduce and have all the kids I'm going to have. And he asked if I would die for an idea. And as he left, I thought about it more. And if you're saying the idea of a quality or, these big ideas that would save lots of people's lives from suffering, I think I would die for an idea. He said, would you die for your country as well, which is an interesting one.
Yeah.
It depends what the consequence would be if I didn't.
One can have these thoughts. You can think about it in the abstract, but it's totally different when you're actually confronted with a decision. And what I don't know is whether or not what I just said would actually be the case in the moment.
And that's why when he said, would you die for your country? I felt like I can't answer that. It would be disrespectful for those that are dying for my country right now.
Yeah, but people do.
Yeah, and people do. And for me to just sit here in this podcasting chair in this hot studio and go, yeah, of course I would, but I'm absolutely not doing that.
Yeah, and if they hadn't, we might not be here today.
That's true. Daniel, thank you.
My pleasure. Thank you.
Do you need a podcast to listen to next? We've discovered that people who liked this episode also tend to absolutely love another recent episode we've done. So I've linked that episode in the description below. I know you'll enjoy it.